Good afternoon, everyone. Let us start solving problems on strain. The first question is, by means of a strain rosette, the following strains have been recorded. So we have the strain rosette values, and it is epsilon 0, that is epsilon at 0 degree, epsilon 45 degree, and epsilon 90 degree. So they have given us the values of all the three strain rosettes that have been used. We need to find the magnitude of principal strains and the orientation, that is the angle of these planes. So let us consider epsilon naught is equal to epsilon x, epsilon 90 degree is equal to epsilon y, and gamma xy, let this be equal to 2 times epsilon 45 minus epsilon naught plus epsilon 90. In the previous class we have discussed about strain rosette, so we have taken the values from there. Alright, so after substituting these respectively, epsilon x is going to be minus 13 into 10 power minus 6, epsilon y is 13 into 10 power minus 6, and then coming to gamma xy, it is going to be 2 into 7.5 into 10 power minus 6 minus of minus 13 into 10 power minus 6 plus 13 into 10 power minus 6. So this term gets cancelled out to 0, hence we are left with 15 into 10 power minus 6. Alright, so let us use the equation epsilon max is equal to, it might be epsilon max, it might be epsilon minimum. Okay, let us call this as comma. So we will be solving for both at once. So it is epsilon x plus epsilon y by 2 plus or minus, plus is for epsilon max, minus is for epsilon minimum, plus or minus 1 by 2 under root of epsilon x minus epsilon y the whole square plus gamma xy square. So we can write epsilon max comma epsilon minimum as, let us substitute minus 13 plus 13 by 2. I will be taking out 10 to the power minus 6 common outside. Alright, so plus or minus 1 by 2 under root of minus 13, then minus 13 into 10 power minus 6 this whole square plus 15 into 10 power minus 6 the whole square. Alright, so this is equal to plus or minus, this whole term gets cancelled, hence plus or minus 15 into 10 power minus 6. Don't forget to write the unit. We can write like this, or we can just leave it without units also, because in the question they have given it as mm per mm. I have used the same thing, else strain is dimensionless. So we have found out magnitude of, this is nothing but magnitude of principal strains. Yes, so we can write epsilon max as 15 into 10 power minus 6, epsilon minimum as minus 15 into 10 power minus 6. Alright, next we are going to solve for the orientation or angle. So in the same equation for the strain rosette, it has been given tan theta is 2 theta is equal to gamma xy divided by epsilon x minus epsilon y. Gamma xy is nothing but 15 into 10 power minus 6, whereas epsilon x and epsilon y is minus 13 of minus 13 into 10 power minus 6. If you solve this, you will be getting a value of minus 0.577, or 2 theta is tan inverse of minus 0.577, that is nothing but 150 degrees, or theta is 150 degrees by 2, that is 75 degrees. Hence, we have found out the orientation of the principal planes, right? So this is the end of this problem. It's a very small problem. We have two types of strain rosettes that we have discussed. So based on the angle that has been mentioned, you need to use the respective formula. If theta 1 is 0 degree, theta 2 is 60 degree, and theta 3 is 120 degree, then it is an equiangular or delta rosette. Here, as in the question, theta 1 is 0 degree, theta 2 is 45 degree, and theta 3 is 90 degree. It is a rectangular strain rosette. So we have made use of the equations given for rectangular strain rosette.